here also we change to minus pi plus in bracket minus 9. So meaning that we want to do in the addition method. But 5 in negative, 9 also in negative. So you need to transform it to the 2's complement for both. 5 also in 2's complement, 9 also in 2's complements. After that, just apply add, and you will get the answer in the blue box here. Okay? So that's why I said master the addition, because later on you will use this one a lot during the midterm test, during the final exam test, everything you will use this one. Also same here, last, this should be discussed here. So any question for this part? Okay, now 47 students. Okay, I don't know where's others. Maybe in bus or flight, everything. Right, so we continue on the subtraction. Okay, like I said it before, even though subtraction we will use as addition. So even the last slide also, we already covered the subtraction actually. Okay, the same method actually, the same method for subtraction here. Okay, for example here, 8 minus 3. You want 8 minus 3. Then we can do here 8 plus minus 3. Same like this. Okay, so make sure that the 3 you need to convert to the 2's complement methods here. Number 3 should be converted into the 2's complement because minus. Then just add here. Then you get the result here. Okay, so subtraction also using the addition method, but you must apply 2's complement. That compulsory, yeah. So multiplication, same. That's a similar method. Multiply 8 multiplied by 3, you get 24. All right. In decimal, it's okay, clear. But in binary, it's not like that lah. All right. So normally multiply also you can change into the additions. 8 multiply by 3. So meaning that you need to add 3 times. 8 plus 8 plus 8 is equal to 24, right? So in binary, you need to do this one, 8 plus 8, you get this result, plus 8 one more, and you get this result. So the last result here, when you convert, you should get 24 in decimal, but the answer in the binary. Okay, or maybe you can use standard procedure if you want to use. For example, here is this one from the books. You can use standard procedure like this. You just multiply plus everything, and you get the last result here. Also, you can use this one if you do not want to use the two's complement method lah. Okay, this one is not two's complement, just multiply, just convert into addition. So addition is more safer and easier to do instead of using the this method. All right, meaning the conventional method here. Okay, same also for the division. Okay, division you can use also in addition methods. Okay, this one example 2 to 3 actually from the books. So I really take from the book because if I want to write one step by step here 2 times, you just scan here. Last time we were using scan lah, all right? Scan and put here. So the question here is divide this one by this one. But if you convert to decimal, meaning that 100 divided by 25. 100 divided by 25. So this is what you do, but you need to do in the binary. You need to do in binary. Okay. Okay. If you can see from here, same also division also we apply the addition method plus two's complement method. to get the result. So you can see that is step 2, 3, 4, 5 actually is come from, okay, like this. So you have 100 minus 25, you get 75, right? So meaning that 100 plus negative 35. So meaning that you need to convert 100 here into binary and 25 also into binary but into complement method because of negative. Then apply additions. So you get this one, right? After that, 75 minus 25, because this one 75, right? The last answer before this, and minus 25 is equal to 50. Or if you want to use addition method plus 2's complement, you must use 17 plus minus 25 is equal to 50. So 70 and plus, minus 25, you will add. Okay, you will get 50 in the decimal and we convert to binary lah. Alright. So if already in binary, so you will get answer in binary for answer for 50. Okay, now 50 is minus 25 or 50 plus minus 25. You get 25, right? So 50 in the binary and 25 also in binary but in two's complement, and you do 4 additions. Okay. Then 25 minus 25, you will get, then you will apply 25 plus minus 25 is equal to 0. Okay. So this one 25 convert to binary and 25 in this one also convert to binary but in two's complement because of negative. Okay. Then do for addition and of course you will get 0, 0, 0, 0 here. Okay. Now you can count how many times you already do here. 1, 2, 3, 4. So the answer should be 4. Right. So 100 divided by 25 is equal to 4. Okay. Is it clear? This one? And of course, I said that in digital system, the question should be clean and clear lah. Okay, and no floating point here should be easier. You just know the method, then you apply. Of course, here you must know two's complement and addition only. Then finish. You can do everything. All right. Okay. That's for the subtraction, division, multiply, and addition. So any question for this part? You have any question, you can ask me before we go for the next hexadecimal and octal. Ada soalan? Nak tanya?
Tak ada doktor.
Okay, kalau tak ada bagilah emoji ke apa kan, at least nampak lah. Tak ada. Okay. Thank you, Tias. Oh, what do you mean, Tias? Others, I don't know. Okay. Okay, we know that online should be, and they have interactions, okay, but at least emoji, okay lah, alright? Okay, so just I want to repeat again. You must know how to do two's complement, and you must know also how to do for addition, and also understand how to do that. Then actually you can do this one, addition using the sign, arithmetic operation for sign numbers. Okay. So now we go for hexadecimal number, because you already learned the binary number, right? So actually almost same as the binary number, only in hexa. Only in hexa. So most digital systems deal with group of bit in even power of 2, as 8, 16, 32, and 64 bit. Okay, hexadecimal use group of 4 bit. So this is the, you need to remember, group of 4 bit hexadecimal. base 16. Okay, 16 possible symbol. So meaning that symbol from 0 to 9 and A to F. So uh, no number 10, no number 11, no number 12, 13, 14, and 15. Alright. So actually 10 is equal to A, it's 1 equal to B, it's 1 equal to C, D, E, and 15 is equal to F. Okay. Hexadecimal, number 10 replaces to A, number 11 replaces to B, and so on until F only because we focus on 8 bit. Okay, allow for convenient handling of long binary strings. So this one is okay. Later on, we will learn this one. So hexadecimal number. Convert from hex to decimal sorry, by multiplying each hex digit by its positional weights. Okay, example. Okay, given you 163 base 16 here. So meaning that this is in hexa. So 163 is actually in hexa forms. Okay. So if you want to convert to decimal, same as uh, binary, we start from 16 power of 0, 16 power of 1, and 16 power of 2, and so on. But here, this example here, this should be 1 here, 6 here, and 3 here. Right. 16 power of 0 is equal to 1. Multiply by 3, you get 3. 16 power of 1 is equal to 16 multiplied by 6. So what do you get here? Okay. Because later on you want to add. So 16 power of 2. Okay. What you get number 256 multiplied by 1 here. So should be 256 lah. Okay. Only here is the mystery number here. Just add, you will get 355 in decimal. Okay. Same as binary, only in the hexadecimal forms. And then convert from decimal to hex. So given for you decimal, then you will convert to hex. Same also in the binary, you must apply the divide by 16. Binary divide by 2, but in hexadecimal, divide by 16. Only the difference here, what do you get here? Only take the floating number here and multiply by 16, you will get here 10. Say, as I said before, 10 is equal to A. Then just took the whole number here, 40, divide by 16, you get 2.5. Only 0.5 here, multiply by 16, you get 8. Okay, this one 8. And 2 divided by 16, and you will get 0.25. Multiply by 16, you will get 2. Alright. Then same here before, stop when whole number equation is 0. So the answer here from LSB to MSB. So 28A in 16 in by and the hexadecimal lah. So you need to write lah. 16 you need to write. 16 hexadecimal, 10 decimal. Okay, later on 8 for octal. Okay, example hex to binary conversion here. So given for your hex binary conversion, 9F2, but previously we said that hexadecimal, we need to, you need to, you need, the bit is, number bit is 4. So should be 4 bit. For example, 9, 10019, 20010 here. So in 4 bit forms, 4 hexadecimals. Okay. So given for you 9F2 hexadecimal, then you want to convert to binary. So 9, so you can see this form is equal to 1001. Just convert F, convert here, 2, convert to here. So just combine everything. This is binary. Actually is equal to 9F2 lah. Alright? But in binary forms. Okay, in binary forms. Okay. Actually, I said that in 4 bit, so meaning that we can split into 4 bit. Okay. This one you can split into 4 bit. So you have here number 2, F, and also a 9 here. Okay. But in clean form, just write the bit binary bit here. 1001 1111 0010. Okay, example of binary to hex conversion. So given for your binary, okay, we can see that in binary number 2 here, then you want to convert it into the hex conversion. As I said before, we need to split into 4 bit, 4 bit, and 4 bit. So we need to split into 4 bit here, and also one more here, 4 bit. Actually, the end of here it should be 0 0 here, okay, because this one is not put here, but we can put here 0 0 1 1, so become 4 bit. Now you have 1 2 and 3. Now 0 1 0 0 0 1 1 0 is equal to 6, 1 0 1 0 is equal to 10, convert it become 8, and 0 0 1 1 is equal to 3. So this is the result for 3A6 in hexadecimal, from binary to hexadecimals. Okay, to do this one, you need to do from LSB to MSB. So this arrow here, LSB to MSB. So okay, for example, 1 0 1 0 0 0 0 1 1 1 0. So you need to start from here to here and split into 4 bit. Split into 4 bit. Okay. Don't start from right to left. This should be from left to right. Okay, actually, that's one for hexadecimal. Uh, just finish for hexadecimal. Later on, end of slide, actually, I will show you how the question is created for you. Okay, now you learn binary, you learn decimal, you learn hexadecimal, you learn octal. So later on, the question will combine everything, and you need to solve that one. All right. So now we go for octal number. So octal use 8 character, the number 0 through 7 to represent number. There is no 8 or 9 character in octal. So octal numbers from 0 to 7. No 8, no 9. Okay. Then after that, we go for 10, 11, 12, 13, 14, 15, 16, 17. Then finish, then they carry on lah. Okay. So normally we learn only for until 15 only lah, because of for the 8-bit position only. But binary number can be easily be converted to octal by grouping bits 3. Okay, hexadecimal grouping bit 4, but octal grouping bit 3 at a time, and writing the equivalent octal character for each group. So, okay, given for you this one, express 10011, so the long number here, right? Then you need to split it into grouping bits 3 from left to right. Okay, meaning that from LSB to MSB. Group into 3. Okay. So what you get here, 110 is equal to 6, 001 is equal to 1, 000 is equal to 0, 011 is equal to 3, 001 is equal to 1, and lastly you can see that only single one, right? Here should be 001. So 001 is equal to 1. So this is the answer in octal. Okay, in octal. You see that? 8 here. So that's why you need to be very careful later on. If question asks you octal, then the result should be octal, and the grouping should be 3. If the question hexadecimal, the answer should be in hexadecimal, meaning base 16, and the group should be base 4. Sorry, the group bit must be 4. Okay, that's the difference between octal and hexadecimal. Okay, this one is the application of octal number. For those in back end for website everything, you will understand if using this one. It's okay. This one is nothing here. Okay, octal also weighted number system. The column weight are power of 8. Okay, binary power of 2, hexadecimal power of 16, but octal is power of 8. Same like binary. So if you can understand binary, you can understand for hexa, you can understand also for octal. Same procedure. Express 3702 in decimal. So you can apply the sum of it. Okay. 8 power of 0 multiply is equal to 1 multiplied by 2. Then 8 power of 1 is equal to 8 multiplied by 0. So this one multiplied by 0. And 8 power of 2 is equal to 64 multiplied by 7. This one. Then 8 power of 3 is equal to 5 power 2 multiplied by 3. You get this one. So 8 plus 0 should be 0 lah here. Then you get the answer for 1986 in decimal. Because question asks you convert it to decimal. And same also if you want to decimal to octal. Okay, binary divide by 2, hexa divide by 16, and octal is divided by 8. Okay, divided by 8. Same procedure as hexa. Take the protein number here, multiply by 8, you get 7, and only 44 put here, you get minus 0.5 here, multiply by 8, you get 4, and 5 here, you get this one, multiply by 8, you get 5. Okay, and stop when you get 0 here. So start from below to top, the answer should be 547x. Alright? Okay. Just remember the procedure of binary, same for hexa, same for octal divide. Only the method is a little bit different. Okay, but hexa and octal almost similar. Okay, we have one more BCD numbers here before I think BCD. Okay. Okay, BCD, we call that binary coded decimal, is another way to present decimal number in binary forms. Okay, what it use and common features of both decimal binary system. Each digit is converted to binary equivalent. So BCD normally we use in the clock. If you have clock, you want to do for clock system, then we use the BCD number. So BCD number also here you can see that 0 to 9, 0 to 9, and the binary also same as 1001, but in BCD until here only, same as BCD, but start from number 10, but in binary is 1010, but for number 10, they will start against 1 here, and 000. So BCD a little bit difference on the represent the number of BCD in the binary system. So you can think of BCD in terms of column weight in group of 4 bit. For a 8-bit BCD number, the column weight are okay like this. Okay, they start from, for example here, 1, 248 4 bit. Then after that, the second here become 10, 20, 40, 80. After that, there should be 100, 200, 400, and 800. And later on 1000, 2000, 4000, and 8000. So this is how the BCD series represents. Okay, it's not like binary, it's not like hexa, and also it's not in octals. Little bit difference. So okay, here the given for your BCD number, you can see in color, green, blue, red, and yellow or orange here. Okay, so in green, yes, 1248. Blue, increment become 10, 20, 40, 18, like before this. And red, hundreds. And in orange here should be thousands. If you have more number, they become more lah. Okay. Now you want to, okay, actually then you can add, siapa tu? Ada soalan kah?
Excuse me, doctor. The screen doesn't show up.
Sorry,
What is the problem with the resolution?
I cannot hear you because they have some echoes. Actually, you want to see my slide, you need to pin my profile because I'm not presented. You need to pin my profile, then you can see my slide.
Okay, doctor.
Okay, now as you can see that only take the binary one, zero, of course. You cannot add everything because of zero multiplied by any numbers become zero. For example, here for green here only 8 and 1. So that's why you just 8 and 1. For blue only for 40 and tens. And for red here is 1 here, meaning that 200 and 100. Just add together here. And for orange color here should be one, last one here, right? Should be 8000. So 8000 here. Just add only that represent ones. Then we get the answer. Okay? So that's why I say that BCD is a little bit different on hexa, octal, and also binary. Okay, to convert the number x74 to BCD, just you can, if x74 is normal binary, right? So x is equal to 1000, 7 is equal to 0111, but in 8 bit, sorry, in 4 bit forms, and 4 is equal to 0100, and just combine together. Okay, just combine together, you get answer in BCD. So if question that BCD, you need to put BCD here. If binary, you put 2. In octal, everything, then you can use that one. 8 to 16. In BCD is BCD. Okay, this one BCD. Okay, actually, just more few slide. Actually, we finish on number system. Okay, we have one more here. Alphanumeric codes. Now, this one only the ASCII, or we call it ASCII number. So widely used in the embedded system if you want to use this one. So this one is okay. All right. Okay, this exercise. Okay, this one I want to show you. Okay, you to understand this chapter, you must do this exercise. Answer is there. Okay. Same also exercise this one. Answer is there. All right. So uh, to understand this chapter, you must do this exercise. Okay. As I said here, this is the question for midterm. Final exam is almost like this one. Okay. given for you 1660 in hexadecimal minus 20 hexadecimal. And number two, I give you in octal, in octal. So you need to find this one, you need to find this one. You can use calculator to check the answer. You can use now. But everything, the solution like this. You must show the solutions. Okay. Even though when you want to add, they have some here, right? You must show also. At least I know that you understand. If this one is not show here, I know that you just use calculator. Alright? So the question like this. Then the question also, they can be maybe 60 hexa minus 20 octal, and what the answer. Can be like that also. Alright. And normally the last from the question, your answer should be in decimal. That's the tricky also. Everything you do, lastly, I need the answer in decimal. Okay, like this. Answer should be 6 power of 10. So this is the last answer. But the question number one, number two is not like that, right? In hexadecimal and octal. But you need to show everything. Okay, you need to show everything here. Okay, from this one, convert to binary. This one also convert to binary and apply two's complement. Why? Okay, why? Because of the question here, minus. Okay, or I can write it again here, 60 plus minus 20. Okay, this form same. So that's why the solution should apply two's complement and addition method, and you get this one and discard. Okay, this is the answer for number one. So number two also convert to binary, and 16 also convert binary, but apply to complement because of minus. Do for addition, you get 2. Okay. Number three, the question said that checksum. Checksum meaning that addition only. So that's why you must plus. Plus what you want to plus here, just plus the answer from you get from here and here. Okay, just add, you get this one. And after you get this one, using sum of weight, get the answer, convert to decimal. This is the last answer. Okay, so this is the process for this chapter. Alright, because next chapter a little bit they become like the new chapter, no continuity from here. Okay, this chapter already finished for this one, how to do calculation everything, and to understand how hexa, octal, BCD, and also in binary everything. And this is the question normally asking for you, lah. Okay. Same also for this one. You need to know, convert, apply, then you must show everything. Okay, answer also is already there here. You can use calculator to check your answer, but the process again, because last time they not show this one. When you do for addition, they have some what we call that balance here, right? But the student not show here. So I assume that you use calculator just to get the answer. Okay. Of course, I punish this one. No marks given. If you show the step, meaning that I know that this one is correct, you get the answer. All right. Okay. For this chapter, please do the exercise. Okay, please do the exercise. Next week, most probably is the online class because already as online class. So maybe after next week, maybe no lab yet. Maybe we try to do for tutorial lah. Alright. Later on, I will inform in the groups. If no tutorials, no lab, I will not inform. If we have, then I will inform. Okay. Okay. Actually, that's all for today. So, you have any question that you want to ask?
No, sir.
Excuse me, doctor.
Huh? Yes.
We can't see the answer. The
The
screen.
answer. Sorry, I'm not clear. What do you mean?
The screen is not clear.
Just download my lecture note lah, the same one. You already registered e-learning or not? So everything I already put in the my e-learnings. You can download. Everything's there, same as I'm a lecture today. Okay? Don't worry about this one. Same as in my lecture notes. So if no further question, then we can stop at 5. Okay, because next chapter is not challenging, but not challenging. I say that it's not continuity from this chapter. Okay, and there are different chapter, but they approach her to go for the labs. All right, this one no lab. Only chapter 2, 3 they will go for the labs. Okay, later on when I will downgrade the size of the file, then I will put in the e-learning for the videos. Okay, thank you everyone, and happy Deepavali for the Indian. All right.
Thank you, Doctor.
Okay, welcome.
Thank you.
Thank you, Doctor.
Okay.
Thank you, Doktor.
Ya, sama.
Thank you, doctor.
Okay.
Thank you, Doctor.
Okay.
Thank you, doctor.
Okay.
Apa, doktor?
Mai makan dia ada kami nak makan nasi ni. Ada training.
Gigi.
Ajak jam je lah.
Boleh.
Balik lah ni, okay. Sampai cuti semua.
Tak boleh balik, doktor. Duduk sabar, duduk sini je lah.
Oh, tak kesiannya lah.
Balik rumah doktor lah, makan maruku.
Saya pun balik kampung.
Oh, okay. Bye, doktor.
Okay. See you.